let's get started. So I'm unmuted. That's the first thing to check. This is good. So hello, everyone. Welcome to Rangle's first Vue meetup of the year. Thank you so much for coming. I'm so happy these are starting up again. So my name's Adam. I work at Rangle on the technology team. And I have to get our introduction stuff out of the way before I hand things over to the speakers. So a quick intro to Rangle, who's hosting this event. We are a product transformation consultancy that partners with enterprise level companies and scale-ups that need to innovate but have no idea where to start. So our teams are pretty skilled and definitely obsessed with turning great ideas into reality and getting them to markets fast. We're very pleased to welcome our two special speaker guests from the VUE Amsterdam community tonight. They are Reinier Kaper and Sybren Willemot. I know I got the last name wrong. That's okay. We'll throw this back screen. If you're excited about the things you're learning tonight, feel free to tweet about them with the hashtag #LearnWithWrangle, and also at Rangle.io. I'm going to repeat that because it said my connection was unstable. So if you're excited about what you're learning tonight, feel free to tweet about it with the hashtag #LearnWithWrangle and at Rangle.io. This way we'll see what people are tweeting about and feeling impacted by, and it'll help us arrange the next topics that we invite speakers to. So with that, I will hand this over to Reinier for the first talk.
All right.
Are you able to share your screen?
Yeah, let's give it a go.
Perfect.
Thanks for the introduction. Let me just get set up here. There we go. Oh, the screen sharing is currently disabled for participants, so probably should enable that.
Or let's make you into a host. There you go.
Got it. That should work. Yeah. Perfect.
Perfect.
All right. Is this visible to everyone? I hope so.
Yes, it is.
Awesome. All right. So let me get started. All right. Well, thanks everyone for attending. Thanks for having me here doing my little talk on state machines. And my talk is titled Writing Better Components with State Machines. And kind of my objective with this talk is it's kind of twofold. On the one hand, I want to get people familiar with the concept of state machines if they're not familiar with them already. And then on the other hand, I also aim to get people excited about using state machines, especially when it comes to writing components, but state machines can be used in various different applications, even on a more broader architectural level. So those are the two things that I try to aim for in this talk. And I will start off by telling you a little bit about myself. I'll promise you I'll keep this short. I'm Reinier Kaper. I am the lead front-end developer at a company called Creative Layer. We are technically a startup, but we actually sprouted out of our previous company called Canvas Pop, where we basically did the whole order and fulfillment part for getting images printed on Canvas. That's where we're originally from. We have quite a bit of experience there, and we started this new company where we basically give store owners, digital store owners, say people on Shopify or on Etsy or on other e-commerce platforms, take away all the burden and the load that they have to deal with when people send them images for print. Usually these are stores that take an image and transform it in some way, make caricatures out of them or something like that, and then send it off to a fulfiller to actually get printed. But that whole process of getting the order in and actually getting it designed is usually manual. Like it gets shipped off to like a team in India or something like that, and all that communication is fairly manual, like through email or whatever. And we built software to basically take that whole process and offer that to people with stores and take away all that sort of pain. So it's sort of an order fulfillment system, you could say. I'm originally from the Netherlands, lived there for 30 years, and then I moved to Canada with my wife, and now we have a daughter as well, and we live in Ottawa. And at Creative Layer, I have a team of 4 front-end developers where we build all kinds of stuff, mainly the product, but we also build other Vue-based libraries like icon libraries and component libraries and stuff like that. That's who I am. You can find me on Twitter and Discord usually under the handle The Dutch Coder. I'm not too active on Twitter, but I follow quite a lot of people, and on Discord I'm more active where I also help out. So if you want to connect, feel free and go there. So as I said, the goal of this talk is to, on the one hand, make people familiar with state machines, like what are they, where did they come from, a little bit of history. And then on the second part is getting you excited, and I'm going to try to do that by showing you, by doing a live demo, live coding demo, and see how you can use them in a component in real life. So, you know, that's always exciting because that usually goes a little bit wrong, but we'll see. So first off, what are state machines actually? So state machines are, they're actually called finite state machines, and they're mathematical models. And they describe the behavior of a system that can be only in one specific state at any given time. And formally, there are 5 parts to state machines. That's you have a finite number of states, a finite number of events, an initial state where your state machine starts off from, a transition function that basically handles events and goes to the next state, and then a set of final states, and that's when the machine is complete. Some machines can be in a sort of never complete state. We'll touch on that later, but that's technically what it is. And I always like to illustrate it with a super simple example, so you get sort of an idea of what the concept is. So in most, at least North American homes, you have some form of climate control, like a heating and a cooling system. Let's say the default for that system is it's off, it's not doing anything. But it could also be in a cooling mode where your house gets nice and cool during the summer, or it can be in a heating mode. So you could say these are 3 different states of the same machine or the same area. To go from one state to another, you could say, hey, well, if the machine is off, if the thermostat is off, I press a button and that makes it go to the cooling mode. You could say that a cool event got sent to the machine. If I press it again, it goes into heating mode, and if I press it again, it goes into the off mode again. So it's a very how do you say it? A very sort of concise way of telling what state any given system can be in at any time. Obviously, in most, especially modern thermostats, you can also go the other way around, and there's all kinds of other things happening. But that's the basic of a state machine. Now, state machines also have a sort of an extension, you could say, and that's called a state chart. And that takes the basic idea of a state machine and kind of amplifies it a little bit. And state charts were actually introduced in 1987. So the whole concept of state machines and state charts is actually very old, relatively old, I should say. And it's been around for a long time. And one of the things, at least I found while getting into state machines, I started asking myself, why wasn't I familiar with this concept sort of from the beginning? It felt like it made a lot of sense, and hopefully after this talk, it does for you as well, and you can find out a little bit more. But state charts build onto state machines, and basically what they do is they give you concepts called like guarded transitions, which mean if you go from one state to the next, you can actually have a piece of functionality there that determines if you should go to the next state or not. So a guard, basically. Then there's actions that you can invoke. For example, in a login event, you try to log in a user and you get the user back. You could store the user in a piece of state, for example, that will be an action. You can have parallel states, super handy for things like form validation or form inputs, where you have multiple inputs, but they're all part of the same form, but one input could be in a valid state and the other input could be in an invalid state. And then the other part is nested states, and that's fantastic because that means you can group states together. For example, if you have a loading state, which should be very familiar for people that build apps or even components, but that loading state could itself be in different states. So for example, it could be loading, fetching users, but also loading, updating users or stuff like that. You still have sort of a grouping that you can be inside of, but still have sort of specific substates you can be in. Sorry, that's one too many. And if I take a practical example of a state machine in a programming sort of context, one really good example is, especially in the world of JavaScript, we deal with async stuff all the time, and that comes in the form of promises, obviously. And a promise itself is actually a state machine. So a promise can be in technically in 4 different states. Actually, it's in 3, but let's assume it's 4. It can be idle, like it hasn't done anything yet. It could be sort of in a loading state, like it's processing, or it could be in a resolved state. And that resolved state can actually be a success or an error state. So technically speaking, you could have 4 states. But a promise itself can be modeled as a state machine. And that really illustrates like how precise sort of those different states are. And also, you can never be in 2 states at the same time. It's always one or the other. And that makes it very predictable and hopefully easy to work with. Specifically for JavaScript, there's a library called XState that basically gives you the ability to use state machines in JavaScript. It's driven by David Khorshid. It's an absolutely excellent library. It's library agnostic, or framework agnostic, I should say. So whether you use Vue or React or any other framework or even vanilla JavaScript, it doesn't matter. It all works with that anyway. But they do have some nice plugins. So for example, they have the XState View plugin, which basically makes it composable out of the state machine functionality so that you can use it easily in your component. This talk, by the way, will all use Vue 3. If you're not familiar yet with Vue 3, some pieces might look unfamiliar, but the concepts are all the same. So basically, the way you use the state machine in a component is pretty much the same in Vue 2 as it is in Vue 3. Just the syntax for getting certain things inside of the template might be a little bit different. So David wrote a fantastic library, and that's actually the one I'm going to use to illustrate how state machines could hopefully make your life a little bit better. So now I will actually start a live coding session, and we'll see if that actually works. I think I have to share a different window for this, because let me just try that 1 second. I think, there we go. Oh boy, it's actually doing per tab. That's not what I wanted. Can I share a whole screen? I cannot. That's unfortunate. All right. I'm honestly not too sure how to proceed with that. Yes. Now people can't see my browser. Adam, would you happen to know if Zoom has the ability, or Zoom has the ability to share the whole screen instead of just one application, because it won't let me for some reason?
Usually you can do that. Let me.
Just give me 1 second, because
I've definitely achieved this before, but
yeah, it's also definitely on one screen. So
I think it'll usually be labeled like desktop 1 or desktop 2.
Oh, I think I should do shit. Hold on. Can I do this?
If you're using a Mac, there might be an extra layer of something you have to grant. Oh no, that looks good.
I think I
Success.
have it. Yeah, I could. I can hold Shift and select multiple windows. I don't know why, for some reason, I don't get my screen, but okay, fair enough. We got it. Crisis averted, I hope. All right. So let's dive into a practical example of using state machines. And the way I've set this up, and hopefully this is a good enough example, is I want to try and write a fairly small component that does some async data fetching. And I want to start off by writing that in what I would consider a sort of traditional way of doing it. And I want to emphasize that doing it this way is there's literally 100,000 different ways of doing it, but it's not the wrong way of doing it. It's just, in my opinion, the normal way of doing things, as most developers will probably do it in some variation. And that I just want to illustrate that at some point you get into a more complicated sort of state management piece, and that's where I think at least state machines really help and can really help people write more predictable components, which in the end is probably much more of a gain than writing clean components or something like that. So why don't we just dive in, and I'm going to write this component that fetches a list of users. It's nothing fancy, but it will illustrate my point, hopefully. So here I have my browser set up. It should all be hot reloading, hopefully, which it does. Is this visible enough to everybody? If not, let me know and I can adjust maybe the scale or something. So let's start off with writing some little methods that we can leverage to fetch our data. And I'm just going to fetch basically a list of static users for now. So let's get this out of the way, and let's say we have some data. It's going to be our users. So we have John, oops. John and Mary, and then let's build a very simple fake API. So I just want to fake the fact that we're fetching data as if you would from a regular API, which we all know are sometimes a bit spotty. It could take a while. So let's do that by writing a promise that just, oops, sets a timeout. And for now, we're just going to resolve whatever data we pass in. Okay. So this is basically when we call this function, it will wait a second and return our data. So that's not too fancy, but let's see how we can use that. Okay, so first we want to store our users somewhere. So let's use a ref for that. If you're not familiar with how refs work in Vue 3, it's pretty much like how the data object in VueTO used to work. It's a bit of a different syntax that you have to get used to. But other than that, it's a reactive value, just like how you would normally be used to it in Vue. So let's write a method that actually fetches our users. And let's store the result from calling that API. And then we want users.value to take on the result. Oops. And that should hopefully, let's see if that works, do something. Oh, we obviously have to fetch them, otherwise it won't do anything. So this will hopefully fetch our users, store the result on our users object here, and then we obviously want to loop through those items. So let's say if we have some users, let's display them. So with a v4, we do that. Oh. Let's key them by ID, and then let's display their name. Oh. So that, and then this one should go. And as you can see, we now, if we reload, it takes a little while, and then our users appear. Great. So this is obviously a super contrived and simple example of how to write a little bit of async fetching, but it illustrates the point, I guess. So now we've set up a little method that gets our users that will resolve after 1 second, and it will display them. Cool. So normally when that happens, when you do anything async, really, most of the time you want to show the user that you're loading something. So showing some sort of loading message or loader, spinner, or whatever is pretty common. So I think that will be a good piece to add next. So let's make another ref that just keeps track of the fact if we're loading something or not. So we set up a loading ref. Sorry. I am just going to. It's not working. Okay. So normally when anything async happens, we do that with a try catch in order to make sure that that we actually get the result we want and otherwise can catch the error. So let's do that. We start off by saying, make sure that we're not loading, right? This is pretty typical, I would say. Try to get our data and set it. If that works, great. If not, well, we have to do something here at some point. And then when everything is said and done, we want to be not loading anymore. Here we want to start loading, obviously. So now when we fetch users, we'll go into sort of a loading state, you could say. And then once it's done, whether it was successful or not, we go into or go out of the loading state. So here, let's just add like a little paragraph that says if we're loading, we show a loading message. Why not? And I have to obviously return that, otherwise it won't be accessible in the template. There we go. Cool. So now every time we're loading, we show a loading message. Again, hopefully this is pretty common for most people that write components like this. This is a pretty standard scenario, I would say. So we have that loading state, and that's great. Now, obviously, something could go wrong. So we also want to catch anything that comes back as an error. So let's first make sure that we actually do get an error back at times. So let's just do a quick math random and resolve that half of the time and otherwise reject it. And just let's just say, oh no, something went wrong. So now half of the time, theoretically speaking, our API will fail and we won't get any users back. So you want to do something with that for your component, obviously. So let's keep track of an error, which can just be a string, because that's what we're actually returning. So set the error value here when things go wrong, expose it to the template. And now when something goes wrong, an error will be set. So we should probably display it to the user. So let's just copy this thing and use something like this, show the message. Okay, let's see if we, as we call it, successfully failed. We did not. I made an error somewhere. Oh boy. The beauty of live coding, I guess. Let me just quickly inspect what's wrong. Oh, that was pretty obvious. There we go. Okay, so now we're loading. Let's see if we can hit an error state. There we go. Okay, so cool. That's great. We have a loading state. We have some error handling. We display it to the user. Now, the only thing is that even though this is a simple component, I hope that a sort of a pattern seems to emerge, or at least to me. There's two different sort of types of data we're storing. On the one hand, we have the actual data that we're displaying, like the users or the error message, but loading is more of a state, right? Like you're either loading or you're not, and obviously that's why it's also a Boolean, but those are two, in my opinion, those are two different things. And once your component starts growing and actually becomes more complex, because this is not so much a real life component, our components are usually way more complicated than that, you start to get that sort of the bleeding of actual data with pieces that influence the states of a component, like how it should display, but it's still all in the same context. And at least personally, I find that sometimes becomes hard to reason about, and especially when you have to handle with or have to deal with edge cases. So for example, if you were to forget to set or reset your loading value, you would get unexpected loading event or loaders showing on your screen. And those things are relatively easy to solve. And most of the time your test would probably catch those scenarios, but it would be a lot nicer if you would not actually have to, think about that. And I think hopefully I can illustrate that with state machines, that's exactly what will happen. But let's make our component a little bit more advanced by giving people an option to retry to fetch the data. So if an error occurs, maybe we want them to reload the data. So actually, I want this to be different style. So let me do that. Okay. So let's make a button that only shows if we're in an error state. And we click it and we want to fetch the users again. So let me expose that to the template so I can actually use it. And we call it retry. Now, obviously, we should reset some stuff now, because if we click that button, we don't want the error message to remain there, or maybe we do, who knows. In my case, in this case, I don't want to. So here, I'm going to say if the values were successfully returned, and previously there was an error, for example, I want the error message to be gone. Because otherwise, what would happen is if I retry, the error message would stay there because I didn't actually reset that piece of state. So let's see what happens. There we go. Perfect. So you saw that the error message was still there while we were fetching the data, but once it resolves, it goes away. You can obviously move that over here so that the error message goes away as soon as you click the button. That's a matter of style, I guess, or preference. Okay. So this is pretty much how basic I want to keep this component. It pretty much does everything it needs. It fetches data. It handles a loading state. It handles an error state. It gives you the option to retry. That's pretty, pretty straightforward. Okay. So the next thing is I want to start using a state machine and use the state machine and write the exact same component, basically, functionally speaking, but hopefully in a much more structured and, in my opinion, nicer way. But before we do that, I'd like to think about the different states that we can be in, because that lies as a basis for anytime you use a state machine. You have to first think about what different states that machine can be in, and it depends what your machine is handling, right? So in this case, I want to write a state machine that basically drives this component. And there's 4 states that I can identify. The first one is an idle state, like the component is there, it's mounted, it's not doing anything yet. The second one is a loading state, so we're fetching our data. The third one is a success state, or in other words, the data was fetched correctly and we're displaying it. And then the fourth is an error state, where we tried to fetch our data, but for some reason it didn't work, and now we're in an error state. So those are the 4 states that our current component, can be in. Now, I quickly touched on the fact that state machines have events, and events trigger moving from one state to another. So in our case, for example, if we're in the idle state, we want to have an event that will trigger the component going into the loading state. I usually call it event fetch or something like that. So we will have a fetch event, and it will move from the idle to the loading state. And then there's another very explicit event called retry. When we're in the error state, I want to send a retry event to retry and fetch the data. Now, you might say, wait a minute, if you go from the error state to the loading state or from the idle state to the loading state, like you could use the same event, and then technically you would be right. If you use the same event and do different transitions with them, that's totally fine. I always like to be very explicit about them. Even though they achieve the same result, going from the error state into loading with a retry event makes it immediately clear to, for example, another developer, what is actually happening or what should be happening in the component. That's maybe the better way of putting it. So I feel like that's a nice way of doing it, but you can totally use the same event. Okay, now let's write the machine for this. So I'm just going to make a JS file, and we're going to write our state machine in here. Or actually, you know what? Let's do it in the component. It might be easier to look at because then everything's together. So let's say we have this fetch machine, and I will be using the machine from xstate. So we import that, and then we can, that's basically an interpreter, or it's not an interpreter, but it will process your machine. And the machine is nothing more than an object. And it has certain things that it requires, and then certain things that you can provide. So let's make the most basic one. First one is you need to give it an ID, just because machines can also interact with each other. Then, as I also touched on at the start of my talk, it needs to know in what state to start, and you call that with the initial. And let's say we have an idle state and we want to start in that state. Then we have a states object, which we'll go into later. And then there's this other piece that's very useful. It's called the context. And context can be used for different things, but usually it's where data that you interact with the machine or get back from a piece of the machine or whatever, you store it there. So here you begin to see the separation that I talked about over here with these variables, where data and things that express state or tell the component what to show are sort of mixed. In a state machine, they're exactly it's exactly the opposite. They're separated hard. So anything that's data goes into context. Anything that tells the machine what it should be doing at this time goes into states. So in this case, we're just going to store users into context, because that's basically our data storage for this component. And then the states we talked about, we determine we have idle, a loading state, a success state, and an error state. And this is basically all you need to configure a state machine. But in order to go from one state to another, we need to implement those events that we talked about. So the fetch and retry event. And the syntax for that is fairly straightforward. It's on, it's basically respond to an event, and you can call this whatever you want. So I'll call this fetch. And then you basically tell it where to go. So in this case, if a fetch event occurs or happens while we're in the idle state, it will move to the loading state. And for the error one, we said we want to have a retry event. And it also moves to the loading state. And again, this could also be fetch, and it will work the exact same way, but I like to be a little bit verbose about this. So our initial state is idle. Whenever this machine starts, it will start in this state, and then will only ever respond to events that are declared within this state. So if I have another event, whatever, foo, it will respond to it. But if there's an event over here in the loading state that with a different name, it won't respond to it because it's not configured to do so. And that's also why I like to be verbose about my events, because if I would have called this fetch again, it's hard for me to, like, if something happens that shouldn't happen, it's hard for me to determine, like, oh, wait, weird. Why is it responding to this fetch event in the error state, but I could be in the idle state, for example, and I don't know. And it's hard for me to determine, like, what's actually going on. Whereas if I have this and I call a fetch event from the error state, I know this will never work because it's never declared. So it's a little bit easier to debug as well, I find. So that's our basic machine. Now, machines have all kinds of tricks up their sleeve, and one thing is it can invoke services, and a service could be something like an API call. Well, that's very convenient because we just wrote that little API thingy over here. So I'll show you what you can do, and it's quite powerful. What you can do is say, if you enter a specific state, so in this case, if we enter the loading state, I want something to trigger. I want something to be done, and you can use a source property for that, and you can tell it which service to run. And I'll get to service in a little bit. And then there's two other very important parameters, and that's, you have the undone call, and that triggers when the fetch or when the invoke was successful. And in this case, I want to go to my success state. And there's also the on error event or handler, basically. And in that case, I want to go to the error state. So basically what this is doing is, if I go into the loading state somehow, I want to invoke a service. And when that service is successful, I go into the success state. And when it fails, it goes into the error state. And services can be provided like this. It's also just an object. And this is the name. This name responds to this string here. So that's the service you call. And then we want to do something. So in this case, we want to just call the API. And the API will resolve or reject at some point. And if it resolves, we end up in the success state. And if it rejects, it goes into the error state. So that's so that's in a nutshell what this machine will do. We'll probably do some more things with it. So once we have called our API, obviously we get some data returned, right? We get the users returned. But right now, we're not really doing anything with that. And this is where another piece of state machines comes in very handy, and that's called actions. And actions, as I said, can do all sorts of things, but usually they set things on the context. So in our case, whenever we get a success event, when our fetch event is successful, I should say, we want the data that comes back to be stored in our context. And we can do that with an action. So instead of directly going to the success state, we're actually going to call some actions, and then we call the target, and this is where you will end up after the action has run. And let's call set users. That's going to be our action. And let's configure our action to actually set our users. And we need one more piece for that. We need the assign function from xState, because we assign things with a function. So this is where we configure our actions. That relates to this one. So we want to have a set user action, and that does something. So set users, and that will assign something to the context. So let's call this context. And then we have an event. So whenever you invoke an action, you get the context of the state machine as a parameter, but you also get the event. And in our case, the event actually came from that service that was called. And the result from that service is what the event contains. So we want to set event.data, and it always comes back as a data property on that event. And you'll see why later, because if you call an action manually, you have to specify a type and the data is exactly the same in this case. So here what happens is, when our fetch was successful, we first run this action. The action sets the users on the context to event.data. And then it will go into the success target, and our component will be in the success state. Okay, so now with that out of the way, I think there's only one little piece left, and that's like if there's an error, we also want to store the error, right? Because we did that in the original component, and right now we have no place for that. So let's just put the error into context. It will just be a string, just like in our original component. But we have to set the error, and we also do that with an action. So let's do the same thing here. We go to the target error in the end, but here we want to say call an action called set error. So let's do that. And in this case, we don't want to set the users, we want to set the error to the event data. And the error comes back as the same thing because the promise of this thing that gets returned contains the .data property contains the message or the users in this case. So that's just how the state machine works. That's the thing you just have to know, kind of. Okay. So now that we have our state machine here, this should theoretically, if I did it correctly, handle all of our different states that we can be in for a component, but also handle all of our data at the same time. So now let's go back to our component and actually use this machine in order to render the data or the different states that we're in. And hopefully during this process, we'll see how this can be really a nice thing to work with. So the first thing we need to do is we need to actually import the composition function for XState. It's called useMachine, and it's an XState plugin for Vue specifically, and that lets you interpret a configured machine so that you can use it in your component. And the syntax for that is fairly straightforward. You just call it with the machine itself as the argument, and then it returns three things. It returns the state and a send function, and the other thing we actually won't be using. But the two most important things are that it returns the state and the send function. And the state is basically a large object with all the current details of the state that the machine is in. It also contains the context where the data is stored, which is very important, which we'll touch on later. And then the send function allows you to actually manually fire off events to the machine. In our case, we need that because we need the retry or the fetch event to be sent to the machine at some point. So we need that function to call those things. I'm actually going to remove everything else. Like, we don't want any of this old stuff in here. But just remember what we try to set out to do. And let's expose these two things to the template so that we can use them. So let's see. Now our component, if we would save this, it would not work because all of these things are no longer returned from the setup function. We now somehow need to use our state machine to get all this information out. That's the goal, right? So let's start with the users first. So the users are stored in what I said before is the context of the state machine. And instead of just having a user property, you could, by the way, use a computer property for this, and it will make your life a little bit easier. But in this case, let's just do it sort of the old school way. On the state object, you have the context object. And within that, as we see here, we have our user. Oh, that's actually users. There will be an error if I did that. Okay. So this is where our users are stored. So instead of having just users.length, we now use state.context.users.length. It's a bit more verbose, but you can clean this up at a later stage. So we also replace this, and then the rest would pretty much stay the same because we still use the same data as before. We just get it from the state machine. So this is where the users come from. Now, for the loading state, state machines have a very nice matcher function, and I'll write it first, and then I'll talk about it because it's a little bit easier to talk about then. So the state has a matches method, and that will return true or false depending on the state the machine is currently in. So this is pretty obvious, I hope, what it does. So if the machine is in the loading state, this will return true. So we could use idle, loading, success, or error in this case. So this basically replaces that Boolean that we manually had to track before. Now it just depends on the state the machine is in. And the nice thing is, for example, if the state's in the machine is in the loading state and our promise resolves with our data, it moves to the success state. So we don't have to set or reset any sort of Booleans that track what state we're in. That just happens. And our matches our template will update depending on that. So that's for the loading state, obviously. Now you could use different state matchers to display different things, which we will do, because in this case we will use it for the error as well. And this one's actually quite important. You'll notice that previously we just checked if the error string was set at all. So if you forget to remove the error will always display. But in this case, we say, no, only display the error if we're in that specific state in the machine. So it makes it so that there's just less room for error, at least in my opinion. It makes it much more verbose. And then the error itself is also stored on the context as this state.context.error, because we defined it as error here in the context. So now this will hopefully only display if there's ever an error. And for that button, that retry button, we can do the same thing. Just if the state is in the error state, we want to show this button. And then we have to figure out how we're going to fetch those users again. And we have to figure out how we're going to get the users in the first place, because this is no longer a method that we have to our disposal. So let's see how we can do that. So first off, when the component is mounted, and in Vue 2 this is a little bit different because you have a hook for it, but the setup method in Vue 3 basically runs when the component successfully mounts, so you don't have to have a hook for it. In here, what we can do is we can tell the machine, because it's in the idle state by default, we can tell it to go into the loading state and fetch our data. And we do that. There's a shorthand for this as well, but I like to use the longer version of this. We can say, send a fetch event, or an event of type fetch, to the machine, and then it should respond to that. And as we declared it here, if we're in the idle state, and only if we're in the idle state, if the machine receives a fetch event, it will go to the loading state and then do its magic here. So that's the first thing we want to do. Now, the retry event was a little bit different because we just send a different event. And if we expose the send function to the template, we can use it just inline. You could also have a handler function here, and then define it in the setup function. Might be a little bit cleaner, so whatever you prefer, but this will work fine. And the nice thing is we can only ever send this event if we're in the error state. That checks out because that button is only visible in the error state. So this should then fire off successfully. So I think let's see what happens if we run this. Look at that. It still works. Let's see if we can get an error event going. Oh no, let's retry. That works. Hit another error event. Let's see if we can get out of that. There we go. All right, so let me just collapse all these things because this is just noise at this point. So what we end up with is this super tiny component. And obviously you can make a component tiny by just moving stuff out of the setup function into its own file or whatever. That's not the point. The point is that we are no longer manually tracking things like the loading state. We don't have to think about setting or resetting the error messages. Technically speaking, the error message will be stored. We don't reset it ever, because if we go into an error state, it will just use that whatever gets returned as the message, so it will update. But you don't. I think the point that I'm trying to make is that you don't have to think about these things anymore because they're dependent on how you've defined your state machine to behave, basically. In my opinion, this makes for incredibly predictable components, and it's not just a nicer way of working, but it just prevents user error because, well, we're all humans and we make tons of error every day. At least I do. And if you can just take one of those variables out of the equation, it just makes it for a much nicer experience. And another nice thing is that if you send an event here, say, I would say the retry event here at the start, and nothing's happening, the thing I know for sure is that I have not configured my machine the right way because it's not responding to this event. That means that the state I'm in is either not the state I think I'm in, or the event I defined is in the wrong state, or it's misspelled or something like that. It becomes very easy to track like where you went wrong. Whereas if you have the blob of code with all kinds of setting and unsetting variables and stuff like that, that's much more hard, or much harder to reason about in my experience. So I just want to note three important things here about this. Every single expression of our UI, so the way our component renders, is completely dependent on the state machine and the state it's in. So the loading message only shows up if we're in the loading state. The error message only shows up if we're in the error state. None of these things interfere with each other. That's super nice in my opinion, because it makes your component very predictable in what it can and can't show. And as we see, the template, let me just take a little bit more real estate here, it's all dependent on the machine. There's no more variables coming from the setup function that you have to use. It's very predictable. The state machine logic is very explicit. You can never be in the loading state and the error state at the same time. It's just not a thing. Obviously, when you work with nested states, so for example, you would have loading dot fetching and you have loading dot updating, for example. You could end up with a case where you're only matching on sort of the parent state, so to speak, and you're updating something and you didn't expect the loader to show. That just has something to do with on what level you drill down to with that matcher function. But technically speaking, you can never be in two states. So everything is very separated. And another thing that I really like is that all the logic of the component is actually in the state machine. You don't have to write the logic for your component in this way. It's just defined in the machine. So the way you set up your machine is the way your component will behave. Obviously, you have to hook it up to the machine in the template, but technically speaking, that's what's happening. So just for the closing thoughts, and then I'll stop talking, I promise. Just to recap, we have moved all our logic of the component into the state machine, which is great. Our component has become purely an expression of the state that the machine is in. And you can't end up in any sort of edge case because you haven't defined an edge case. And that's a nice thing. Like, obviously, state machines can become incredibly complex, and you will get into edge cases just because of how complicated the machine itself is. But your machine is only ever in a state that you tell it to be in. And if that's not the right thing, then you just haven't defined it properly yet, or it's too broad or too specific or something like that. So all your logic is now in that machine, and that really makes for much fewer edge cases. And it's also a very nice tool when you do, like, for example, TDD. Writing state machines can really be a very nice way of doing that, because you think about your component from a state level first, before you even write your single line of templating code. So yeah, that's really my talk. Hopefully, this was a good illustration of what you could do with state machines. Again, it's not limited to writing components. I literally have built pieces of global state managers, kind of like Vuex or Vuex, whatever you want to call it. But then as a state machine, it has a wide array of applications. And hopefully, if anything, this intrigued you and you're like, hey, I should probably check this out, and maybe, maybe it's fun to use. Definitely check out the XState documentation that David wrote. They also have a super cool visualizer where you can write your little state machine, and it will actually show you a diagram of how things are connected, and you can step through it with events. It's brilliant. So yeah, that's really it for my live coding piece. That's really it. I can answer some questions. I'm not an expert on state machines, but hopefully I can answer a question or two. So maybe if there's any questions, let me know.
I'll ask one there, Reinier. Can the target of the undone handler be conditional? Like, is it possible that once a handler's finished and it's done, depending on the data it's done with, you might go to 2 possible next states, or does that violate what you're supposed to be doing with the state machine?
No, that's a great question. Yes, you can. So I briefly touched on, but did not illustrate guarded transitions. And guarded transitions are exactly that. So you could have an inline guard that says, hey, if my event.data, I don't know, is an array or an object or something, I want to go into one state, but if it's a string, I want to go into another state. So you can totally do that, and that's totally fine, as long as if you explicitly define those states, obviously, because otherwise it won't work. Then that's a totally legit way of doing it. I personally don't really use it because, in all honesty, the state machines I tend to use on a day-to-day basis are relatively simple. I would say that they're sometimes big and they do a lot of things, but the complexity of them I try to keep low because I use it for a lot of components, and I feel like components should be relatively easy or like small. But yeah, it's a totally valid way of doing it. Yeah, great question.
So based on what you just said there, are you saying that you sometimes have a defined state machine that is the basis for multiple different components? Like you could have 3 components sharing the same state machine definition, or do you tend to go one-to-one?
Well, yes to both. I tend to go one-to-one, but there are exceptions. So a good one is so we use Amplify with a GraphQL layer, and a lot of the data fetching in our components happens in exactly the same way with just a different query. And in that case, it would make sense to write a data fetching state machine that does all the things for every single component the same, but for example, takes in a query string as a parameter, or maybe even a function that calls an endpoint or whatever, but handles all the processes, all the data, all the states it can go through in the same way. So you can definitely and probably should reuse your state machines if that makes sense. But in a lot of cases, I tend to just write one-off state machines because most of the components we write are different enough, so to speak. But yeah, for the small ones that just grab data from somewhere and show a spinner and then show a success or error message, definitely you should reuse your state machines, and you can, yeah.
If there's nobody else, I will move us on to the next talk.
Awesome. All right. Thanks so much.
Thank you, Reinier. So next up is Sybren. Are you still here? There you are.
Yeah, hello. I'm still here.
Nice.
Awesome.
Yeah.
All right, let's.
All yours.
All right, let's just fly in and try to, get a co-host, and then share my screen. But I guess you still need to make me co-host if that's
Exactly.
right. All right, awesome. Thank you.
Oh, and I might need Natalia to do that.
1 second. You should be good to go.
All right, awesome. Okay, let's see. Should be sharing right now.
Success.
Awesome. Okay. Well, thanks for having me. I'm Sybren, and I will be talking about Chakra UI Vue Chidori, the V1 version. So yeah, this is it. What it does, it's a component library to make beautiful UIs. So, for example, this Airbnb card. In my talk, I will get you started with it, and then after it, you can try and have fun with it. So let's start with introducing myself. I'm Sybren Willemot, and I'm a front-end developer at Uricom, and I'm from Belgium. So it's midnight, past midnight for me, but that's all cool. I'm a core member of the Chakra UI Vue library, and also one of the co-organizers of the Bellevue and the Worldview Meetup. Currently, we're a bit on holiday mode. On Twitter and on Discord, you can find me under the handle Carwick. And if you have any questions, please ask them after my talk, and or reach out to me on Twitter or Discord. So in school, a few years ago, I started with CSS for styling my applications. I think most of you guys did that, and I learned it wasn't the most fun way to do it, but it worked out, and I got what I wanted. And then I learned about CSS, for example, preprocessors, and this made my life easier because we had nested selectors, variables, etc. And I also learned about libraries, because in school we didn't use libraries. And somehow I don't know why we didn't use it, because it really made my developer experience better. I like using libraries like Tailwind, 55, Bulma, etc. And after a talk from Maria Almardo at VUE Amsterdam a few editions ago, I realized that accessibility is really important nowadays on the web. And that's made me learning about area standards, keyboard interactions, and a lot more. And all this just came together for me when I learned about Chakra UI. I learned about Chakra UI Vue when it's on the previous version of it, so the V0, which is VueTO compatible. And I rolled in and somehow became part of the core members, and now we are working on our V1 version, Chidori.
Sorry to interrupt for a sec. You
Yeah.
might be sharing the wrong screen, because we can see your speaker notes rather than the whole slide.
Okay. Really? That's okay. Well, let's see if I can swap it. Stop share. Speakers note, well, everybody can read, so.
It's not so bad, but if it wasn't what you intended.
Yeah, it's not what I intended, but thanks for letting me know. Yeah, I see now the chats. Yeah, thanks for letting me know. Let's see. So now you are hopefully seeing my presentation. Okay, cool.
It's the same one, but we can roll with it.
Why is it the same one? Just figure it out. I'll just try it one more time and then we'll roll with it. Okay, let's share. Now we're good. Now we're good. All right. let's go. Let's back up one more slide. So I was talking about the Chakra UI Vue V1. So this is the latest one we're working on. It's currently in experimental alpha, but you already can use it. And I know there are at least 2 or 3 pages that are running in production with Chakra, so that's really cool. If you aren't a Vue developer, but I think most of you are, there is also a React version, and this one is up to date with the latest React version. So Chakra UI Vue tutorial, I already said it's component library, so it delivers components to style your applications, and not like Tailwind where you have to use CSS classes, etc. The focus lays on accessibility, and when components and with the components that come from the library, you can build your Vue applications with speed. The V1 tutorial is fully compatible with Vue 3 and is built in TypeScript. And and there is also an extensible theming API. So by default, there is a theme object that comes with Chakra, but you can customize it the way you want to make your application look the way you want it. So what I already said was it's in alpha right now, DV1. But if you want to use it in production, there is the V0, and it's compatible with VueTO. So, all right, getting started. Let's assume we got a Vite project. I mean, a Vue 3 project scaffolded with Vite because it's really awesome, really fast. And once we have done that, we just can add the Chakra UI package with the yarn command or npm install. And before we can use the Chakra components, we have to add it to the Vue instance. So in our main.js file or main.js file, depends on what you want to use, we first import the plugin, the Chakra UI Vue plugin from the package. And then we have to tell the Vue instance that we want to use the plugin. It's really simple, just .use and then the plugin. And then we are ready to go and using the components. So components, I like to compare them with Lego blocks because you have all types of Lego blocks, and each Lego block has its own thing that it does. Same with components. You have all types of components, and each has its own thing. And then you can style them and build your own application with it. So how does this translate in Chakra? So Chakra has these components, for example, a box component and a button component, very basic components. And you can import those in your project. I'm sorry, just from the package. And under the components option, you can put those there. There is also a tool under development that will have auto import of the Chakra components. So this all falls away and it's less code. The components itself, once you have imported them, they are ready to use in the template. And yeah, it's very basic. Simply add the corresponding tags in your template, and yeah, you're ready to go. So now the styling of those components, which is important, of course. Back to the Lego blocks. By default, Chakra has a theme object, and that by default will style the components. For example, we have this default 2x2 blue block, and with style props, these are properties that you can pass to the component. You can make it look like, for example, a 2x4 or maybe this kinds or this kinds, or this. It's really all up to you. So how does this look in code? So we have our component, a very basic box component, and this is just like translated into a div. And with these style props, you can just add them. For example, here we want to change the text color. There is an option to do it with raw CSS color value, as in the first one, or with a color from the theme object. The theme object has a lot of colors already built in. They would think it's based on the Tailwind one. And it is also the last example, a prop for changing the background. Here it's BG, and that's the shorthand for background. So yeah, it's really handy, less code to type. And behind the screen or behind the scene, Chakra will generate CSS classes from this. For example, on the right side. And those generated classes have a low priority, so they can be easily overwritten if you want to, if you need to, if you still need to. So the theming, the theme objects like this, for example, this is small theme viewer. The theme object is a JavaScript object that contains a lot of stuff like colors, shadows, borders, spacings. And it's already some default values, for example, all these colors or all these sizes. And since the V1, there is also defaults in the theme object for components. Like you have a base style, you have the variants and sizes, etc., all in the theme object now. And this theme object can be customized the way you want. So how can we customize this basic default theme object? We do have a function called extend theme, and with this function provides you with all the access you need to the theme and lets you override and extend the default theme. So for example, we want to add new colors to our default theme. We can use the option extend theme in the plugin options and then add our new colors. For example, I know that primary is already a default color in the theme object, but with the new value, it will override this. So now it will look like this color. And the brand colors, they don't exist yet, so they will be added at the bottom of the colors color object in the theme object. And yeah, right now I put it all in my main.ts file, but yeah, of course, it's possible to have it in a separate file. And yeah. So I said that since the V1, there is a new thing that's component theming, and it lets you customize your Chakra components. For example, you can customize the default styles, you can customize the variants, the sizes. And there is also a thing now that's called the Chakra function, factory function. And this function chakrifies your components. More on that later. So let's see. For the components, they come with a base style, like I said, but you can override them with the extend theme function. And inside the theme object, there is a components key, and where you can find, for example, button. And there you have base styles. And inside the base styles, you can put all the values you want to override. And the new style will be inherited for all the Chakra buttons, for example, in the application. Let's see. So I got some small amazing demos from Jonathan. He's another core member of the Chakra UI Vue team. And yeah, it's just small examples on how he here creates overrides the base style of the button. So let's see if it works. It should be. So he has this basic checkout button, and he creates a theme.js file. for his extended team. He already puts the extended team function in there. And then he goes under components, under base style, and changes the values he wants. And he overrides color, for example, the font family, and all the other properties. And once you have done that, you will have to import the extended team to the plugin. So that will be done in the main.js file, like here. So we import the team from the file and then tells the plugin, hey, I want to extend the team. And by default, the button now is overwritten and has this, as you could see, purple borders and color. All right. Okay, that's the next one. So next slide. So that's pretty cool. And yeah, now all the colors he would, all the buttons he would create would be would have this default styling. So now it's also possible to have custom variants. There are already a few existing variants for components. For example, for the button, I know there is a ghost button, a ghost variant, inline, outline, etc., solid and stuff. But now you can create your own custom variants, and yeah, just the same way as you did for the base style, just under the variants key. Let's see how Jonathan does it in the demo. So he starts out with creating a new button. It's more like a cancel button, but it is obviously doesn't want them to be the same or looking the same. So in his team object, he will create a new variant under the variants, and I call it primary. And yeah, add some values to it. For example, change the background and the color. And once he has done that, he can go to his template in the Vue app.vue and just say the style prop variant and change it to primary. And now the checkout button will be purple. It has a purple background. Hope that's all clear. I really don't see the chat now somehow. So I will look at it after my talk. I'm sorry about that if you already have questions. Okay, let's see. This is just the button again. Okay. Then one last thing is sizes. Is if there is a size that doesn't exist yet, you can create a new one in the team object, and yeah, it's just the same as before, but under the sizes key. And so Jonathan here has created a few buttons with all sizes that already exist, for example, size large, etc. But now we want a button that is even larger than large, and it's a mega size. This will be broken or yeah, doesn't look like it's mega because it doesn't exist yet in the team object. So yeah, he goes here under variants. He adds the sizes. This should be, you'll fix it later in the code. It should be under the sizes key instead of directly in there. But it changes to the styles he wants. And when he has done that, he can use the size everywhere on the buttons. So yeah, here we'll be fixing its typo. And then you will see that the mega button will be like really mega. And it's really cool because you can create one size and use it all over your project, as you can see here. So the last thing, and it's my favorite thing, is the Chakra factory function. And it lets you chakrify your Vue components and DOM elements. So your own component, like for example, my component here in the code, or even DOM element like A tags, image tags, header tags, whatever, can be put through the function. And then it will return a new new component, let's say, that you can style with style props the way you could you do it with Chakra components. And yeah, then you can use these components in your templates and have fun with it. So last demo from Jonathan. Let's see. So he has this hello world component. It's a small component. It's just a counter, if I'm correct. And so he put it in his template right there. And right now, just passes the prop to it, the message prop. But if it tries to change the background, for example, it doesn't change because it's not chakrified, let's say. So we import the chakra function, chakra factory function called chakra from the package, and then passes the hello world components through it. So if it changes to the chakra version, and it should be all right. Yeah, there you go. You see the background changes to red, and now we can use all the style props to make it look the way you want to. So that's really awesome, and yeah, that makes it already production ready for me. The only downside is the accessibility will be lost with this. So yeah, let's see. No, we already had this. So yeah, that's kind of all I wanted to tell you about, and you should be ready to start with Chakra UI Vue now. There are a lot more things to discover, of course, and there will be still a lot more things coming for the Vue 1. Like I said, the auto import, for example, and a lot more components than there already are. So let's see, there is on the website next.vue.chakra.ui, there is a code sandbox where you can already play around in. It has this Airbnb card example. So for example, it looks like this. Here you can see the chakra.image. This is an image tag passed through the chakra function. I know right now we have to update this because in the latest version, we do have a text component for Chakra, so that's really awesome. And if you have any questions or want to help out or meet new people, feel free to join the Chakra Discord. It's a chat Discord with the React group. So let's end with this slides of links, useful links. I will be posting my slides on Twitter if you want to check them out again. So first of all, it's of course the Chakra Chidori docs. Second thing will be the Discord invites to the Chakra UI Discord. The third link is just the code sandbox to the code sandbox links to the Airbnb card example. And the last link, the YouTube video, is the talk from Maria Lamardo, where I learned about accessibility and how important it is. All right, thank you. And let's see if I can dive into the chat. I probably just stop share and then I'll see the chat. All right, awesome. So if anyone has a question, please feel free.
Maybe there's none.
All right, and I hope it was inspiring. And well, if you're trying State Machine out, maybe try Chakra to style your demo application. Thanks for having me.
You're welcome. Thanks for staying up crazy late so you could be here with us.
That's okay. It was really fun.
Awesome. And I think with that, we're good to call it a wrap on this meetup. So thank you everyone for coming and sticking around. Thank you, Sybren and Reinier, for presenting. We are off to a good start for the year. Yeah.
My pleasure. It was a lot of fun. Thanks for having me.
Thank you, both speakers. Excellent.